Right now, somewhere beyond the orbit of Jupiter, an object is crossing the solar system on a path no planet invited it to take. It has no known family, no gravitational master, and no clear intention. Its name is 3I Atlas. When the Atlas survey team in Chile first flagged the blurry anomaly in early July 2025, it looked like another non-event, another icy wanderer, another designation, another file in the planetary database. But it didn't move like anything local, and it didn't reflect light like anything native. Follow-up analysis showed a hyperbolic orbit, the kind of trajectory that means it isn't just visiting through, never to return. Only two such interstellar objects had ever been confirmed before: Oumuamua in 2017 and Borisov in 2019. This was number 3. Within weeks, the observations turned from curious to unsettling. The object's velocity was higher than expected. Its rotation was erratic. Spectroscopic readings showed compounds not just unusual, but seemingly incompatible with what we understand about comet chemistry. Instead of settling into a predictable curve toward the sun, it began shifting subtly, almost resisting the gravitational math that usually governs such encounters. By late August, observatories across the globe had turned their instruments toward 3I Atlas. The excitement was tempered by something else, a shared discomfort that no one wanted to speak aloud. Something about the timing, the trajectory, the proximity to Mars. Mars. The red planet had spent years in the limelight of speculative fiction and scientific ambition alike. Home to more robotic explorers than any other world, and the target of Earth's long-term colonization dreams. In September 2025, Mars was nearing opposition, closest to Earth in its orbit, fully illuminated. And 3I Atlas was on a path that would take it within just 0.30 astronomical units of it. That's about 19 million kilometers. In cosmic terms, whisper close. The official line from space agencies was clear: no impact risk, no threat to human life, no deviation from planned missions. But the math was laced with caveats. Observations were ongoing. Perturbations were possible. The object's non-gravitational acceleration, a gentle but measurable push likely from outgassing, made future predictions increasingly unreliable. The no-threat statement came with an asterisk. What if that asterisk grew? History reminds us that space is full of near misses. Asteroids that skate past our planet within lunar distances. Comets that fragment unexpectedly. But what happens when a truly alien object threads that needle, headed straight for one of our solar system's most precious assets? At NASA's Jet Propulsion Laboratory, models were updated hourly. At the European Space Agency, simulations ran day and night. Still, one truth remained. The most dangerous approach vector for any object is the one from behind the sun, and that's where 3I Atlas would be during closest pass. The planet Mars has no protective magnetic field. Its atmosphere is thin, incapable of burning up large incoming debris. Its surface holds the legacy of impacts plainly: great basins and craters, ancient and fresh alike. And if something were to hit it, even a fragment, we would know instantly, because 6 orbiters and 3 surface rovers would be there to witness it. The question is, would they survive to report it? As the object drifts toward solar conjunction, slipping into observational darkness, the world is left with a strange sense of waiting. Not panic, but a mental leaning forward. One of those moments in human history where everything seems stable. Yet beneath the surface, the machinery of the cosmos continues its slow, indifferent work. Sleep, if you can, but listen closely, and in the morning, let me know what you would do if something from another star decided Mars was in its way. In the stillness of early September skies, the object disappeared, not into space, but into sunlight. As 3I Atlas moved behind the sun from Earth's perspective, it entered a stretch of weeks where no telescope on Earth could track it. Even the most advanced solar observatories were powerless against the blinding glare. This wasn't unusual. Many objects cross behind the sun. It's a routine pause in observational data. But Atlas wasn't routine, and the timing wasn't helpful. Before it vanished from view, 3I Atlas had shown signs of instability. The coma, the envelope of gas and dust that often surrounds a comet, had begun to pulse irregularly. Jets of material rich in carbon and something else still unidentified erupted in intervals that defied thermal modeling. The body wasn't just warming, it was reacting. Astronomers call this non-gravitational acceleration. It's a term that sounds precise, but hides uncertainty. As material vents from the surface of a comet-like object, it acts like a series of tiny thrusters, pushing the object off course. When those jets fire unpredictably, forecasts break down. Trajectories shift. What was once a clean arc becomes a guess. And this one was heading toward Mars. The Martian sky, if you stood on the surface, would give you no clue. Thin, rust-colored air. Occasional gusts stirring the dust. Nothing remarkable. Perseverance, the rover stationed in Jezero Crater, continued its slow crawl across ancient sediment. Ingenuity, its flying companion, had recently completed its Eta first flight. Everything on the red planet, from the orbiters above to the drills below, operated under the assumption of normalcy. But above it all, somewhere in that space between certainty and silence, a question hovered. What if Atlas had changed course? Even a minor fragment, a sliver from a disrupted nucleus, could alter the script. It wouldn't need to be large. Mars's thin atmosphere means that even medium-sized objects can reach the ground intact. The energy released upon impact would be massive, not extinction level, but enough to erase a crater, a lander, or a story we were just beginning to tell. Back on Earth, simulations multiplied. At the University of Arizona, a team ran scenarios showing what might happen if a single 40-meter chunk from 3I Atlas broke off and struck Mars at an angle. The most likely result? A localized explosion equivalent to several megatons of TNT. Dust thrown dozens of kilometers into the air. Temporary atmospheric darkening, radio blackouts, and most importantly, the disruption of orbital communications. Mars orbit is crowded. Satellites from NASA, ESA, India, the UAE, all sharing the same neighborhood. A single untracked object could cause a cascade, like a cue ball sent spinning into a tightly packed triangle. Still, none of this was confirmed. The official line remained unchanged. No impact predicted. But with the object hidden in solar conjunction, there were no new updates, only time and silence. And that silence began to weigh on people in strange ways. News networks didn't report on it, not directly, but discussion forums filled with speculative maps. Amateur astronomers whispered about the black weeks, when even the most powerful instruments were blind. Somewhere, beyond the reach of cameras and code, 3I Atlas continued its journey. But the solar system isn't just rock and dust. It's a network, a web of communications, probes, ambitions, all balanced on the quiet assumption that space behaves. If Atlas breaks that assumption even just a little, what happens next will echo across more than just one planet. So rest well. Let the hum of the machines above Mars continue uninterrupted. But understand, they're watching too, or at least they were. What do you do when the object you're studying refuses to behave like an object? The question, posed quietly in an internal memo from the European Space Agency's Near-Earth Object Coordination Center, wasn't rhetorical. It was prompted by the last set of telemetry data received before 3I Atlas vanished behind the sun. The trajectory showed minor drift, expected under the circumstances. But the drift was neither linear nor fully accounted for by known outgassing behavior. It was as if the object paused, then adjusted. Not dramatically, not enough to trigger alarms, but enough that veteran orbital analysts stared a little longer at their screens that night. If 3I Atlas were merely a comet, an ice and dust relic of another star system, then thermal acceleration should follow consistent physical principles. Instead, the object behaved like something trying to resist those principles. The jets didn't align with solar heating. The rotational tumble was irregular, but not chaotic. Some of the venting activity appeared to occur on the planet-facing side, which, if the object were actively controlled, would make sense. But this was not a spacecraft, or at least that was the assumption. No one in the professional astronomy community would say the word. Not officially, but in message boards, in private conversations, and in half-joking headlines from fringe websites, the idea began to percolate. Not that the object was artificial, just that something was different, more structured than it should be. Still, Mars spun beneath it, oblivious, a planet of silence and sediment. On September 12th, a brief window opened. One of the solar observatories equipped with coronagraph instruments caught a partial silhouette of the object as it skimmed the edge of visibility. The image was crude, distorted by the intense brightness of the solar limb. But one thing was clear. 3I Atlas had fragmented, a split, two major bodies, possibly more. Fragmentation isn't rare in cometary objects. Many disintegrate when approaching perihelion, the point nearest to the sun. Thermal stresses, volatile outgassing, internal cavitation, all contribute. But this break occurred before peak heating and at a distance that should have been safe. Suddenly, every simulation had to be rerun. Two bodies meant two trajectories, two potential encounter points, two sets of variables, each less predictable than before. And one of them was on course to intersect Mars's orbital path more closely than the original. Impact? No, not likely, not yet. But not likely became the operative phrase in press releases, carefully chosen with enough distance from certainty to cover possibilities no one wanted to outline. At NASA's Deep Space Network, attempts were made to reacquire telemetry using radio reflections from Martian orbiters. The effort failed. The signal scatter from the sun was too intense, so humanity waited again, watching a planet we had never truly visited in person, and a stranger from another system moving in its direction. If a fragment were to strike Mars, it wouldn't shatter the planet, it wouldn't send shock waves to Earth, but it would change things. We would have a before and an after, in terms of science, of certainty, of the way we understand the solar system as a stage and ourselves as its quiet audience. And maybe that's what 3I Atlas was always going to do, not destroy, but remind us that space doesn't owe us clarity, or safety, or sleep. It only offers motion and silence and the chance to listen if we choose to. Somewhere over the Valles Marineris, the longest canyon in the solar system, a sensor blinked out. It was a momentary event, a single data gap, the kind that happens often on Mars. Dust interference, solar noise, a hiccup in a decades-old circuit. Engineers at ESA flagged it, logged it, moved on. But then it happened again. This time, from another orbiter, and then again. Over the course of 27 minutes, 3 separate orbital assets around Mars reported temporary loss of signal lock. Brief, seconds-long episodes of unexplained disruption. Not full blackouts, just a kind of stutter. A pause, like a skipped heartbeat in a system designed for constant rhythm. By itself, this meant nothing. Mars is a hard place. Even in orbit, conditions are volatile. High-energy particles from the sun, electrostatic buildup, micrometeoroid impacts, all can cause anomalies. But the timing. September 16th, 2025, right in the middle of solar conjunction, the period when Earth and Mars align on opposite sides of the sun, making communication unreliable. It was the one time no human signal could reach Mars clearly, and no Martian signal could reach us without distortion. In that silence, something passed between. Back on Earth, astronomers were working blind. The fragments of 3I Atlas, now fully separated, were unreachable by optical means. The sun remained a wall, not of material, but of light and interference. Only low-frequency solar observatories, designed for monitoring deep coronal mass ejections, could glimpse the edges of motion. Those glimpses hinted that fragment B, the smaller of the two, had increased velocity. Not by much. Just enough to change its predicted approach vector by a few thousand kilometers. That shift made it intersect with Mars's orbital path. Precisely. Not grazing, crossing. The chance of impact still minimal, but no longer negligible. Planetary defense protocols don't typically extend to Mars. The red planet, beautiful and distant, holds no life we know of and no infrastructure we consider critical. But that assumption is changing. Mars is no longer just a planet. It's a portfolio of robots, satellites, data, dreams. Billions of dollars and decades of work orbit its rust-colored surface. And with each passing hour, more attention turned toward the object we could no longer see. Somewhere in those days of silence, agencies began coordinating, quietly. Protocols meant for Earth were repurposed. What assets would be vulnerable? What secondary systems could be deployed? If telemetry were lost, how long before it could be reestablished? It was preparation without panic. A rehearsal held in shadows. And then came the dust, not from Mars, but from the object itself. Solar wind particles, analyzed by Earth-orbiting instruments, detected an anomaly in the inbound heliospheric stream, a spike in ionized carbon chains. Complex, heavy, not native. This wasn't cometary dust as we understood it. The particles were moving faster, and they carried electrical signatures that interfered with magnetospheric instruments for hours. In other words, the object had started shedding, outgassing on a scale measurable across interplanetary space. For Mars, this meant more than a light show. It meant exposure. The particles would reach the planet before the object did, carried by the solar wind, accelerated by the sun's invisible breath. The atmosphere of Mars, thin and unshielded, offered little resistance. No one knew what those particles would do. Would they ionize the upper layers? Trigger auroras? Interact with spacecraft electronics? It was too soon to say. But on Jezero Crater, Perseverance's ultraviolet sensors recorded something new. a faint green shimmer across the horizon. Not an aurora, not quite, but close. There are no sunsets on Mars the way we know them. No amber skies slowly fading to violet. Just a dimming, a collapse of light into dust, and sometimes, if you're looking at just the right moment, a strange reversal, a pale blue afterglow instead of red. On the evening of September 17, 2025, orbiters recorded something that didn't belong to that pattern. Above the Tharsis region, a high-altitude cloud formation appeared, narrow, filament-like, electric in geometry, too thin for ice, too persistent for dust. It glowed faintly in the infrared spectrum, registering temperatures far colder than typical mesospheric conditions. Instruments aboard India's Mars orbiter mission flagged the structure as anomalous, not in form, but in altitude. It was too high, higher than any weather ever recorded on Mars. At the same time, Mars Express detected a spike in atmospheric conductivity across the equatorial band. That signal, quiet but distinct, was consistent with ionization from above, not from below, not from the crust nor volcanic activity, from space. Back on Earth, the solar wind stream carrying particles from 3I Atlas continued to ripple across instruments. Earth's own magnetosphere absorbed the energy without trouble, but radio telescopes noticed flickering noise patterns even in deep sky arrays. The interference resembled auroral scatter, but there was no storm. What there was, however, was structure. The particles from Atlas weren't moving chaotically. Spectral analysis showed periodicity, repetition, a kind of rhythm in the dispersion. That rhythm didn't match known solar cycles, nor did it match the rotation of the object. It was something else, a byproduct of fragmentation, perhaps, or something intrinsic to the object's formation. It was, as one astrophysicist phrased it, too elegant. On Mars, the rovers still operated normally. Perseverance continued its slow trek across dried riverbeds. Curiosity scanned nearby ridgelines. Ingenuity remained grounded, awaiting optimal flight conditions. But the data streams showed low-level anomalies, voltage drops, static pulses, spectrometer interference. Individually, none of it was alarming, but taken together, they formed a pattern of disruption, a background hum that hadn't been there before. Meanwhile, the twin fragments of 3I Atlas remained hidden from view, their trajectories updated hourly by software models feeding off incomplete data, ghosting through space like questions without answers. And then came the message, not from Mars, not from Earth, from MAVEN, NASA's Mars Atmosphere and Volatile Evolution spacecraft, which had been orbiting the planet since 2014. On a routine data burst scheduled for downlink, MAVEN transmitted a compressed telemetry packet containing ultraviolet scans of the upper atmosphere. Among the data, a frame-by-frame capture of a transient emission event, a flash, less than half a second, narrowband, centered at 267 nanometers. Unusual, but not impossible. Except for one thing, the emission had a distinct double peak. Double peaks like that in the ultraviolet band are rare in natural processes. They appear in laboratory settings, under conditions involving controlled plasma reactions, in fusion research, in magnetically confined energy bursts. And here it was, over Mars. No one called it artificial, but no one called it natural either. The debate was quiet, intentional, no press release, no internal alert. Just a shared understanding across teams that this would be examined and re-examined for months to come. Because whatever passed over the equator of Mars that night, it didn't behave like dust. It behaved like a message in motion, In space, signals don't just vanish. They degrade, they smear into static, they stretch into silence over distance, but they don't stop all at once, not unless something gets in the way. On September 18th at 0342 UTC, the Mars Reconnaissance Orbiter went silent. The loss wasn't total. Telemetry continued. Power levels were stable. Attitude control remained nominal. But one subsystem, HiRISE, the High-Resolution Imaging Science Experiment, failed to respond to data collection commands. The camera, which had taken tens of thousands of images of Mars's surface, simply refused to activate. It was the most powerful camera ever sent to another planet, and it had blinked. Engineers ran diagnostics. No overheating, no memory failure, no known faults. Commands were resent. Alternate protocols attempted. Still, the instrument stayed dark. A few kilobytes of non-standard voltage readings were logged before the dropout. Then nothing. At the same time, a localized magnetic disturbance passed over Mars's northern hemisphere. MAVEN detected the shift first, a low-frequency fluctuation in the crustal magnetic remnants that litter Mars's ancient rock layers. It wasn't an earthquake, it wasn't solar, it was localized, focused, as if the magnetic memory of a region had been disturbed. Such things aren't unheard of. Mars, though lacking a global magnetic field, still carries fossil remnants in its crust. Under the right conditions, those can be perturbed. But the event was so brief and so narrowly confined that it stood out. The region affected? A stretch of plateau not far from Olympus Mons. No probes were there, no rovers, just data, just traces. But within hours, that data spread through back channels, across agencies, across time zones. The coincidence of timing, HiRISE failure, magnetic spike, still unseen object fragments passing near Mars, was too tight to ignore. And still, the silence held. No visual confirmation, no direct observation, just numbers. And the numbers suggested proximity. Fragment B, now increasingly treated as a separate entity from its parent object, had accelerated further. The simulations revised its closest approach to just over 9,000 kilometers from the Martian surface. That figure was, by cosmic standards, a skim. Close enough that any outgassed material could directly interact with the exosphere. Close enough that electromagnetic fields might ripple into orbit. Close enough that one slip, one unexpected jet of expelled mass, could bring the fragment down. Was it big enough to survive entry? Unclear. Was it solid? Possibly not. But speed, not size, determines violence in space. And 3I Atlas, or what was left of it, had speed. In Earth orbit, geostationary satellites operate at around 35,000 kilometers above the surface. Fragment B would pass Mars at less than a third of that distance, closer than any known object of interstellar origin had ever come to a planetary body. The scale of the event was not yet historical, but it was becoming intimate. So the question that had begun quietly in research rooms now echoed wider. Not, will it hit? But will we know if it does? Because with solar conjunction still in effect, the flow of information from Mars remained broken. Radio silence wasn't just possible, it was expected. If anything did occur, if a fragment struck the surface, if a magnetic field was disturbed, if a signal was lost, we wouldn't know until the planet emerged from behind the sun. And by then, the story might already be over, or just beginning. Somewhere behind the sun, Mars was changing. No headlines, no alarms, just time passing, data missing, and orbits continuing in silence. By September 20th, Earth-based observations remained blind. Solar conjunctions still blocked direct communication. The only information trickling through came from modeling, dynamic simulations recalculated hourly using gravitational drift, solar wind vectors, and best guesses. Fragment B, now nicknamed the filament by a small group of astronomers, had veered slightly once again. The change was subtle within the margin of error, but consistent with prior behavior, unpredictable, directionally biased, and not fully explainable by known forces. At this stage, theories fractured into two camps. One side insisted the object was still behaving naturally. Cometary jets, uneven mass distribution, non-uniform sublimation, all within the realm of established physics. The other side wasn't so sure. The key concern wasn't the trajectory. It was what the object left behind. Dust streams, elongated narrow plumes, had begun to propagate outward from the fragment. Solar coronagraphs, filtering the glare at the sun's edge, caught faint signatures of these trails. They curved against the solar wind, trailing not like random dispersal, but like ordered wakes. Dust shouldn't do that, at least not without something organizing it. Was it magnetic? Was it reactive? Or was it something else? Meanwhile, the thin upper atmosphere of Mars, the exosphere, had begun registering strange returns in MAVEN's archived data. Ionized particles, rich in cyanogen and diatomic carbon, rare but not unprecedented. What was unprecedented was their energy state. They were moving too fast, faster than typical solar wind delivery, faster than local ionization processes. Instruments designed to measure gentle breezes were now recording sharp gusts. On Earth, one particular lab, a Plasma Dynamics Research Center in Kyoto, ran independent modeling. The data from MAVEN matched theoretical signatures of interaction between directed plasma flow and unshielded metallic surfaces. In other words, it looked like Mars had been brushed by something energetic, maybe even focused, and Mars has no magnetosphere to deflect such things, which brought the focus back to its orbiters, still silent, still expected, still unknown. Then, on September 21st, the solar angle shifted just enough for limited downlink testing. The first signal came from ESA's Trace Gas Orbiter. Telemetry arrived garbled, incomplete, but it arrived. Power systems, stable. Attitude control, nominal. Instruments, partially responsive. But the science package reported memory inconsistencies. Blocks of stored data from the previous 72 hours were marked corrupted. Not lost, just unreadable. As if the instrument had recorded something it couldn't process. The metaphor used internally, like a camera trying to capture a frequency it wasn't built for. The second signal came from India's Mars Orbiter mission. Its status was better. Images from mid-September began uploading slowly. Most were unremarkable. Terrain scans, atmospheric bands, but one showed something different. A streak. Diagonal, high in the upper atmosphere, visible in infrared, moving too fast for weather, too slow for meteor. Triangulated with solar wind data, its direction aligned with the predicted arc of Fragment B's tail. No impact, no explosion, no visible entry plume. But something had touched Mars. Not deeply, not destructively, but clearly. And now, as the planet edged out of conjunction, the flow of data would increase. The story would continue, and perhaps it would begin to explain itself. Specifically, a narrow-band ultraviolet pulse detected by MAVEN's backup sensors, not during the pass of Fragment B, but afterward. It lasted less than 2 seconds, but its shape matched a familiar signature, auroral excitation. Except this was different. Auroras on Mars are rare, Without a global magnetic field, they appear only in localized patches where ancient magnetic crust survives. But this event was broad, sweeping. It arced across regions that should have been magnetically dead. And it wasn't green, like Earth's auroras, it was violet. Color is a function of gas composition and energy. In this case, the glow suggested high-energy interaction with carbon dioxide, Mars's dominant atmospheric gas, but in a state not previously recorded, as if the particles involved were carrying more than just velocity, more than just mass. By September 23rd, Mars was moving steadily out of solar conjunction. Ground stations on Earth began to regain consistent lock with orbiters. Data came slowly at first, compressed, incomplete, but it came. The HiRISE camera aboard Mars Reconnaissance Orbiter, previously dormant, returned to partial functionality. Its imaging logs showed a gap from September 17th to the 19th. No explanation, no flagged error, just a clean void where commands had been acknowledged, but no pictures recorded. Then, on the 20th, the system resumed as if nothing had happened. The first image captured after reactivation was a routine surface mosaic over the northern plains. Except, in the upper margin, barely within frame, something hung in the sky, a shape, blurred, faint, not cloud, not dust, not empty. Enhancement revealed a semi-symmetric object, diagonal orientation, possibly rotating, scale uncertain, but altitude estimated at 80 kilometers, right on the edge of where Mars's atmosphere fades into space. The official logs didn't name it. The file was tagged Atmospheric Anomaly Reviewed. But off the record, discussion began. Had Fragment B actually entered the atmosphere? Was this a piece of it, a remnant caught in slow descent? Or was it something else entirely? The question remained open, but the data stream deepened. On September 24th, Curiosity, still operational after more than a decade, transmitted spectral data from a rock formation it had scanned days earlier. The readings included trace elements not previously observed on Martian soil, fluorinated silicates, extremely rare in known geology, and not consistent with known Martian crust. Could it be contamination from a micrometeoroid, a sampling error, or fallout? The location, Gale Crater, lay hundreds of kilometers from the predicted dust path of Fragment B. But wind on Mars doesn't behave like on Earth. Thin air moves fine particles across great distances. If Atlas had shed material even in upper atmosphere, deposition across the surface was possible and unpredictable. One theory, floated in a late-night data meeting, suggested charged particles from the fragment's tail may have bonded with local materials upon descent, forming exotic compounds under low-pressure conditions. It was speculative, borderline fringe, but nothing else made sense. The idea that Mars had been marked, not struck, not scarred, but altered, by something older than the solar system was beginning to gain quiet traction. Not in press releases, not in public briefings, but in the way scientists paused before explaining what they saw, in the way certain files were tagged for later review, in the way Mars, once just a stage for exploration, now seemed involved, as if the planet had joined the story, whether it wanted to or not. Mars doesn't answer back. That's what mission controllers say when a command goes out and nothing returns. Not failure, just quiet. But this time, the quiet felt heavier. On September 25th, the Mars Atmosphere and Volatile Evolution spacecraft, MAVEN, sent its full backlog of solar wind interaction data from the week of the conjunction. Tucked among it, was a set of magnetometer readings from an orbit that coincided almost perfectly with Fragment B's closest predicted pass. The data spike was sharp, brief, and unusual, a field disturbance measuring nearly 40 nanoteslas, minor on Earth, but significant for Mars, which has no global magnetism to speak of. The direction of the spike pointed outward, away from the planet, as if something had pushed through. What followed was stranger. Over the next 48 hours, ground stations recorded micro-variations in the signal timing of orbiters around Mars. Not data loss, just minor, repeating offsets in telemetry timestamps. Instruments seemed to be receiving commands milliseconds before those commands were sent. An error? A clock drift? It was possible. But across multiple platforms? Across different nations' spacecraft? That was harder to explain. One interpretation, quietly suggested in a closed-door workshop, was signal reflection, that something in Mars' orbit was bouncing transmissions back, slightly misaligned. Not enough to disrupt operations, just enough to notice. But nothing had been detected. No new object, no debris field, just interference. Still, the surface rovers went on. Perseverance drilled a new core sample from a shallow shelf along the Jezero Delta. The material showed high sulfate content, typical for that region. But buried in the mass spectrometry data was an irregular spike in nitrogen compounds, particularly a rare isotope not commonly found on Mars. The lab teams flagged it for reanalysis. Cross-contamination? Possibly. Instrument miscalibration? Always a risk. Or perhaps something airborne had settled there, something from above, something that hadn't been there before. It wasn't proof, not yet. But patterns were beginning to emerge, and not just in the data. Publicly, news about 3I Atlas had faded. Without visible impact or confirmed damage, media attention waned. The world moved on. Privately, more and more researchers were marking the event as an anomaly, the kind that doesn't fit any known model and doesn't go away. The term non-natural never appeared in official documentation, but the phrase non-random did, because randomness implies chaos. And this wasn't chaos. It was rhythm, the ionization trails, the timestamp distortions, the anomalous isotopes. Each thing on its own was explainable, but together they formed a cadence, the kind you don't notice until it repeats. And now, some began to wonder if there was rhythm. Could there also be intent? Not intelligence, not a message, just a pattern so foreign it felt deliberate. Mars, in its thin hush of atmosphere and dry riverbeds, offered no response. But in the telemetry, in the numbers, something was beginning to take shape. A silence, not of absence, but of arrangement. You don't expect memory to shift in a machine. Code runs, data writes, time passes. But on September 26th, engineers reviewing Curiosity's internal logs noticed a discrepancy. The rover's onboard clock had corrected itself, not by seconds, but by microseconds. Normally, that's meaningless. Systems drift slightly over time. They self-correct using orbiters or scheduled calibration packets. Except during solar conjunction, those packets don't arrive. And Curiosity hadn't received one. Its internal chronometer had realigned itself precisely during a period when it should have had no external reference. The correction matched the timing offset observed in orbiters days earlier. Across systems, across platforms, across agencies, Mars had synchronized. To what? There was no answer, and that, more than anything, set off quiet alarms. Because even if the alignment was coincidental, even if it was a byproduct of solar particle interference, The scale of correlation was difficult to dismiss. Data systems are isolated. Rovers don't talk to orbiters directly. Each uses its own protocols, its own radiation shielding, its own logic. And yet, all had twitched. Elsewhere on Mars, a more visible anomaly emerged. The Emirates Mars mission, HOPE, transmitted new atmospheric readings from the thermosphere. In the data, a temperature inversion, warm air overlaying cooler layers at altitudes too high for normal convection. Not a global event, a pocket, stable, persistent. The inversion was centered along the same latitude where MAVEN had recorded its ultraviolet flash days earlier. Some theorized that ionized particles from Fragment B's tail had created temporary heating, like a slow-motion aurora. Others proposed that dust had altered the thermal radiance balance. But the energy required to sustain the inversion exceeded known inputs. Something had deposited heat in a structured way, and it was still doing it. For now, the planet remained visually unchanged. No impact craters, no visible scars, nothing to show the world, just data. But within that data, more signs accumulated, small things. Frequency overlaps in orbiter transponders, repeating voltage fluctuations in Perseverance's core drill, subtle harmonics in wind sensor recordings, vibrations too regular to be natural, yet too weak to classify as mechanical. Together, these fragments formed a pattern of quiet disruption. Mars had been touched, not violently, but intricately, and whether that contact was over or only just beginning remained unknown. As the planet emerged fully from behind the sun, its orbit returning to visibility, one final uncertainty took shape. The larger fragment, Fragment A, still unseen, still unaccounted for, still coming. It had been 21 days since 3I Atlas was first flagged for fragmentation. In that time, the smaller fragment, the one that passed near Mars, had made its quiet mark, in dust, in radiation, in memory. But the larger fragment, designated Fragment A, remained unobserved, not absent, just unseen. Telescopes trained on the outbound arc of Atlas's original trajectory found nothing. No reflected light, no silhouette, no movement distinguishable from the background star field, and yet the models held. Based on initial velocity, angular momentum, and mass distribution, Fragment A should have emerged from behind the sun. It should have been visible, tracked, predictable. Instead, there was just space. But space isn't empty. And on September 27th, Earth's L1 monitoring station, the Solar and Heliospheric Observatory, detected a faint dip in proton flux from a narrow angle near the sun's limb. The deviation lasted less than 6 minutes. But in that gap, background radiation dropped by 0.7%. That's not supposed to happen. Interstellar particles don't block solar wind. They don't shield radiation. They don't cast shadows at the scale that instruments would detect, unless they're massive, unless they're cold, unless they're built for it. Still, no one said it. Not in the official logs, not in the science briefs. Instead, the report referred to the event as a flux interruption, a phrase designed to say nothing. But a small working group in Pasadena, analyzing solar backscatter, proposed a more daring hypothesis. Fragment A had changed vector. It wasn't following the original outbound curve at all. It had decelerated. That was the word they used. Decelerated, not drifted, not veered, not perturbed. It had lost speed, and that was impossible. Nothing decelerates in deep space without an external force. There's no atmosphere to resist motion, no terrain to absorb energy, unless the object is venting mass or being pulled or it's doing something else entirely. The idea that it had chosen a different course was not published, but it was spoken, quietly, carefully. And now the question returned. Where is it going? Because if Fragment A had not exited the solar system, and if it was no longer heading away from Mars, then only one possibility remained. It was slowing down toward something, something still within reach, something close. There are no breaks in space, only forces and choices. On September 28th, the Deep Space Network Station in Canberra detected a weak thermal signature drifting against the backdrop of Scorpius. It was faint, just a few degrees above the cosmic microwave background, but persistent, and it was moving. Initial parallax calculations placed the object beyond the orbit of Mars, but short of Jupiter. A strange pocket, gravitationally unstable, mostly empty. Nothing should have been there, nothing visible, but the signature held infrared, not optical, cold, radiating just enough to be noticed, just little enough to evade classification. What made it more unsettling was the direction. It wasn't leaving the solar system, it was curling inward. The trajectory once plotted drew a wide, lazy spiral, not ballistic, not parabolic, controlled, a kind of deceleration arc consistent with retrograde mass shedding, or something far less understood. Somewhere, Fragment A had altered course. It wasn't just passing through, it was navigating. For planetary scientists, the implications were difficult to process. No natural body in recorded observation had ever done this. Even Oumuamua, strange as it was, obeyed Newton. This didn't. As the signature grew clearer, teams worked to model its mass. Early estimates were alarming, several hundred meters across, possibly more. It was large enough to host internal processes, large enough to survive atmospheric entry, large enough to matter, and the curve of its new path intersected, once again, with Mars. The planet by now had returned to full communication with Earth. Data flow was constant. Rovers moved, orbiters pinged, but none of them had eyes in deep space. None could see what was coming. On Earth, a contingency plan was quietly reopened. It was a document drafted in 2024, a theoretical response to low-probability extraterrestrial material impact scenarios. Not for Earth, for Mars. It outlined chain of command protocols, data preservation priorities, contamination containment, evacuation, if ever applicable. Of course, there were no humans on Mars, not yet. But what was on the planet had value: satellites, experiments, rovers, memory. And if something large was now on a path toward that surface, something untracked by conventional radar, undetected by light, visible only in heat, the scenario shifted. It was no longer a question of collision. It was a question of arrival, not at random, not by chance, but by return. Because Fragment A hadn't just decelerated, it had curved back toward the one planet in this system already touched by its smaller half, as if completing something, as if circling in. Some signals don't announce themselves, they just refuse to be ignored. On September 30th, a pattern began to emerge in the background telemetry from Mars orbiters, not in their primary instruments, but in their diagnostic noise, the low-level electromagnetic hiss that every spacecraft produces as it talks to itself. Normally, this noise is random, entropic, meaningless. Now, it wasn't. Analysts at ESA noticed it first, a faint oscillation cycling every 17.8 seconds. It was buried under telemetry compression, almost imperceptible unless viewed across long time spans. Then it appeared again, In the UAE's orbiter, in NASA's MAVEN, in JAXA's Deep Space Relay, all operating independently, all reporting the same anomaly, a shared rhythm in the static. Radio engineers tried to dismiss it. Power harmonics, telemetry overlap, maybe a cross-feed glitch. But the frequencies didn't match internal clocks. They didn't match solar modulation. And crucially, they didn't originate on Earth. The pulses came from Mars' orbit, not from a satellite, not from a rover, from space, unmodulated, non-information bearing, just a timing pattern, a presence, as if something was counting. Meanwhile, infrared tracking of Fragment A continued. The object, now confirmed to be over 700 meters in length, remained thermally dark, its surface absorbing solar radiation without visible emission. No albedo, no reflection, just mass and motion. Its course held steady, a shallow approach. Velocity decreasing by fractional degrees per hour. Mars lay ahead, still weeks from projected closest pass. But something else was already here. Dust monitors aboard the Mars Reconnaissance Orbiter picked up particulate shifts, microscopic carbon chains, embedded with nickel-iron residues not consistent with Martian origin. The particles were traced back to high atmosphere, descending slowly, not from Mars, not from meteor trails, from above, from orbit. This contradicted basic mechanics. Dust doesn't fall from stable orbit. It decays, it spirals, it interacts. Unless something is releasing it, purposely. Back on Earth, a closed-door briefing convened at the United Nations Office for Outer Space Affairs. The topic: unidentified interplanetary objects and potential pre-impact material distribution. The phrase used was chillingly simple: slow seeding. Not because of what it implied, but because no one could prove it wasn't happening. And while Earth remained untouched, Mars was becoming saturated, not with destruction, but with alteration. From the thin atmosphere to the isotopic crust to the electrical hum in its orbit, the planet was no longer just a target. It was becoming an environment, prepared for something, or by something. And in that silence, the counting continued. You don't need a message to know you've been contacted. Sometimes the absence of randomness is enough. By October 1st, the pulse pattern from Mars' orbit had shifted, still cycling, but now every 14.3 seconds. The change was precise, instantaneous across all affected platforms. Not drift, not error, a unified recalibration. That's not how anomalies behave. Across mission control rooms on 3 continents, system engineers checked and rechecked their data. Every line of code, every antenna alignment, every timestamp. Still the pulses held, faint, regular, featureless. Some suggested it was nothing, a phantom signal, interference. But then came the alignment. Instruments on board ESA's trace gas orbiter detected a chemical bloom in the upper Martian atmosphere. Trace elements, peroxides, nitrates, reactive oxygen species. Normally rare, usually transient, but this bloom was stable, and it pulsed, with a half-life curve that rose and fell every 14.3 seconds, exactly matching the orbital signal. The molecules weren't just reacting, they were responding. To what? No one knew. And then the ground began to shift, not seismically, but chemically. Perseverance's instruments, scanning a basalt shelf at the edge of Jezero Crater, recorded something strange, repeating fluctuations in surface charge. Positive, then neutral. Positive again. It was as if the regolith itself was entering a charge cycle on a planet with no thunderstorms, no ionosphere, no obvious driver. The local dust lifted, not blown by wind, but levitated electrostatically. For 6 minutes, the rover's cameras caught fine particles dancing upward and falling slowly, in sync with a rhythmic pulse no Martian process could explain. And above it all, still unseen, the curve of Fragment A arced closer. Infrared tracking remained difficult. The object's emissions were erratic, sometimes vanishing altogether, as if the heat itself were being masked. Some theorized layered composition, others advanced radiative cooling. The more speculative theories went further, but no one could explain why its course remained so perfect, so smooth. Natural objects wobble, they precess, they shed. Fragment A glided. By October 2nd, new data from MAVEN's Langmuir probe showed transient electron density spikes at orbital altitudes, microbursts occurring exactly on the pulse interval. This wasn't random interference, it was timing, measured, orchestrated, and someone quietly finally said it. This was behavior, not radiation, not debris, not residue. It was an object, and it was doing something. There are moments when science pauses, not for lack of data, but for lack of precedent. On October 3rd, the pulse from Mars orbit stopped. Not faded, not disrupted. It ended, cleanly, as if a system had powered down or switched modes. Across every affected orbiter, background telemetry returned to nominal. Noise stabilized, diagnostics normalized. The rhythm, 14.3 seconds, held for nearly 4 days, was gone. The sky was quiet again, but it didn't feel like relief. In Pasadena, analysts reconstructed the final pulses, each one identical, until the last. The last pulse carried a slight delay, 0.27 milliseconds longer than all others, statistically insignificant, physically meaningless, but not if it was deliberate, because if the pulses were a clock, then the delay was a comma, a pause before something else, and something else did arrive. Hope, the UAE's orbiter, recorded a sudden drop in thermospheric density above the southern hemisphere. The change wasn't large, barely 3%, but it occurred over just 19 seconds. No solar flare, no dust event, no known mechanism. The drop suggested mass displacement, as if something had entered orbit, quietly, softly, at speed, but nothing was visible. Still, Mars's thin air rippled. The chemical bloom in the upper atmosphere, which had been stable for days, collapsed. Readings from MAVEN showed oxidation products vanishing. Peroxide counts fell. Reactive nitrogen compounds dispersed. It was as if the reaction had consumed itself or been turned off. And then, on October 4th, a signal. Not from Mars, not from Earth, but from a deep space relay node orbiting Lagrange point 1. The signal was narrowband, faint, repeating, encoded, but simple. A sequence of primes, 2, 3, 5, 7, 11, sent in binary tone pulses. No modulation, no carrier wave, just math. It came from the direction of Mars. It lasted 8 minutes, and then stopped. The pulse frequency matched the orbital rhythm that had disappeared the day before. There was no attempt to hide it, but no repeat came. Analysts debated. Was it a natural emission mimicking intentional structure, a byproduct of plasma resonance, a software glitch, or was it something else? The SETI Institute logged it as non-anomalous, probable artificial structure pending review. But the phrase that caught attention internally was different. Protocol Zero candidate. Protocol Zero, a theoretical framework drafted but never activated for first non-hostile signal contact. It didn't require language. It required pattern, order, intention, not proof, just possibility. And now, for the first time, Earth had received such a signal from within the solar system. From Mars orbit, where nothing was supposed to be, and where something, still unobserved, still unnamed, had begun to change the rules. By October 7th, the word was no longer avoided, craft. It appeared first in an internal memo from the European Southern Observatory, then in a footnote in a JPL trajectory model, and finally in an encrypted message between the heads of 5 space agencies. No longer an object, not just a mass, not just a signal, a craft, still unresponsive, still non-interactive, but too consistent in motion, too controlled in energy output, and too aligned in behavior to be anything else. And still, it remained unseen. The hexagonal silhouette, caught by ESA's ultraviolet frame, was reprocessed. Image sharpening revealed surface striations, linear, equidistant, possibly structural. No known natural formation could explain the geometry. Somewhere above Mars, something was holding position, not in orbit, not descending, hovering at a stable altitude of approximately 78 kilometers, too high for parachutes, too low for satellites. Within the dead layer, where atmosphere thins into space and nothing lingers for long. But it lingered. Meanwhile, surface observations shifted. Perseverance, rolling across Jezero's fractured delta, recorded a series of low-frequency ground tremors, imperceptible to human senses, but captured by the rover's seismic microphones. Rhythmic, non-seismic, unrelated to tectonics or impacts. When processed through frequency analysis, the tremors formed a repeating pattern. 7 pulses, pause, 5 pulses, pause, 13 pulses. Prime numbers, again, not in orbit, but in the ground, on a planet that doesn't speak. Something was speaking through it. The tremors were localized, appearing only in one sector of Jezero, never repeating in other locations. They never exceeded safe limits, never disrupted hardware. They simply continued, subtle, measured, intentional. And that night, from Maven's long-range visual sensor, something flickered across the limb of Mars. A flash, not a beacon, not a laser, just a diffuse reflection, not solar, not orbital, and moving. Just for a moment, the craft became visible. Barely. Enough for range estimation. It had dropped. Altitude, 63 kilometers, still above ground, still in the dead layer, but now in motion, downward, slow, controlled, not a fall, a descent. There are no breaks in thin air, only intention. By October 8th, the craft's descent had stabilized at an altitude of 52 kilometers, still far above the surface, still below typical orbital paths. No known aerial vehicle, terrestrial or otherwise, operates efficiently in this band. It's too dense for stable orbit, too sparse for sustained flight, and yet the object held. No flaring, no vapor trail, no signature of aerodynamic stress, only motion, clean, deliberate. It moved in a slow lateral arc across the Martian sky, west to east, tracing a line above the equator. No ground installations lay beneath. No orbiters passed nearby. But every 37 minutes, it pulsed. Again. This time, the signal wasn't prime numbers. It was harmonic. A deep, oscillating frequency recorded across multiple instruments. Maven heard it in the magnetometer. Curiosity caught it in vibration data. Even Earth-based radio arrays detected faint synchronous scatter from Mars's upper atmosphere, as if the planet itself had become a speaker. The frequency, 1994 hertz sub-audible, but steady and accompanied by light. On October 9th, the Emirates Mars mission captured a band of infrared emissions stretching nearly 1,200 kilometers across the southern hemisphere. Faint, curved, aligned with the craft's projected path. It wasn't heat, it was structure. a band of charged particles forming a ribbon, suspended, slowly dispersing, as if something had written across the sky in invisible ink, visible only in infrared. The emissions bore signature traces of noble gases, xenon, argon, krypton, elements not normally concentrated in Mars's atmosphere, elements associated with propulsion systems or containment. And then, from the surface, something impossible, a shadow. Perseverance's HazCam, oriented upward for routine sky monitoring, recorded a momentary decrease in ambient light, not a cloud, not dust, a distinct occlusion moving across the upper atmosphere. It lasted less than 6 seconds. Then the light returned. The rover's internal clock noted a 0.4-second delay in its own systems. Power remained stable, no errors logged. But something had passed overhead, without noise, without contact, but not without trace. Because in the hours that followed, seismic monitors in Jezero recorded another pattern, this one different, binary. 2 pulses, 1 pause, 2 again. Then a single extended vibration lasting nearly 90 seconds, like a cord held in stone. Somewhere above, the craft stopped moving. It now hovered at 46 kilometers. And the message had changed. It was no longer numbers. It was presence. There is a point where observation becomes participation. By October 10th, the Martian environment was responding, not in theory, not in speculation, in chemistry. ESA's Trace Gas Orbiter recorded a sudden reconfiguration of atmospheric isotopes over a 200-kilometer corridor beneath the craft's new flight path. The ratio of oxygen-18 to oxygen-16 had shifted, subtly but consistently, forming a longitudinal band across the sky. This kind of variation isn't unheard of in Earth's stratosphere, but on Mars, where atmospheric mixing is minimal, it suggested something more directed, as if molecules were being selected, sorted. Below on the surface, Curiosity's ultraviolet spectrometer captured scattered readings of fluorescence, a rare phenomenon under Martian conditions. The light wasn't visible to the rover's cameras, but it was there, a glow refracted off minerals triggered by wavelengths not naturally present in solar radiation. Something was shining downward, not continuously, not with heat, with information. Meanwhile, Perseverance recorded its first operational error in over 6 months. Not a failure, a pause. The rover entered a brief delay state, frozen for 1.3 seconds, then resumed all functions as normal. Internal diagnostics flagged a timing conflict between onboard systems, but engineers couldn't replicate it in simulation. What's more, the same anomaly occurred within 30 minutes on China's Tianwen-1 orbiter. Identical duration, identical system behavior, separated by 300 kilometers, synchronized, as if both systems had been interrupted, lightly, deliberately, by something external, not damaged, just touched. And then came the most direct change yet. Hope Orbiter's high-resolution imaging system recorded a faint structure at the edge of Mars's limb. Not orbiting, falling, a small object, no more than 3 meters across, drifting down from the main craft's last known position. Shape, spheroid, descent rate, controlled, trajectory, vertical. It disappeared into the lower atmosphere without trace. No impact was recorded, no plume, no shockwave. But in the minutes after entry, MAVEN's magnetometer picked up a sustained field distortion across the southern highlands. Weak, diffuse, but real. Something had landed or been deployed, and wherever it went, it had not announced itself. By October 11th, the descent object, the small spheroid from orbit, had vanished from all tracking. No radar return, no optical flash, no seismic impact. It was as if it had passed through the atmosphere rather than into it. Still, its presence lingered. Roughly 7 hours after the entry, new chemical markers appeared in the Martian regolith. Not everywhere, only in a narrow ellipse northwest of Gale Crater. The pattern was detected first by orbital spectrometers scanning for hydration traces. At first glance, the readings suggested chlorinated organics, molecules previously debated in Mars science as possible indicators of ancient life or perchlorate contamination. But this was different. The molecules were not bound in salt. They were suspended loosely in silicate dust, and they were fresh. No known geological process on Mars could account for their sudden appearance. The wind had not changed. No storm had passed. The ground had not been disturbed, but something had left them there. Down on the surface, Curiosity's spectrometer confirmed the anomaly and something else. The readings showed mirror symmetry, not in shape, in chirality. The molecules were uniformly left-handed, a feature consistent with biological preference on Earth, but unheard of in abiotic Martian chemistry. It wasn't proof of life, but it was proof of selection, and selection implies intention. Meanwhile, the sky remained still. The craft, the larger one, had not moved from its altitude of 46 kilometers, but its presence had begun to manifest in new ways. Dust patterns across the equatorial plains shifted without wind. Electrostatic discharges, previously rare, now flickered along high ridges. And the Martian magnetosphere, normally faint and patchy, surged in certain regions, forming temporary arcs of localized shielding, as if preparing for what no one knew. But then something changed in the data. In a single frame captured by ESA's orbiter, the craft's outline altered. Not drift, not motion, structure. Panels that hadn't been visible before were now partially extended, angular, symmetric, geometric. The shape was changing, not by erosion, not by impact, by design. Design implies purpose, and purpose implies the possibility of sequence. By October 12th, the sequence had begun. The craft's external geometry, once featureless, now showed repeating symmetry. In new images processed by MAVEN's visual system, 4 radiating struts extended from the central hexagon, each oriented toward magnetic north. The configuration was not aerodynamic. It was not solar. It was positional. The orientation held as the craft slowly rotated, once every 91 minutes, maintaining its altitude while sweeping its radial arms across the upper atmosphere. Each pass left a trail, faint, chemical. High-altitude samplers detected elevated levels of trihydrogen cations, H3+, a short-lived ion that usually breaks apart under solar radiation. Here, it persisted, not globally, just in arcs, like brushstrokes across the sky. The ions aligned with each radial sweep, a marking system, or something more functional. Closer to the surface, the environment continued to shift. Perseverance's meteorological station logged a steady increase in atmospheric opacity, not from dust, but from suspended particulates with unusual reflectance properties. The light-scattering profile suggested microcrystalline structures, not sharp, not random, spherical. Engineers proposed a comparison: hollow glass beads, like those used in retroreflective coatings. On Earth, such structures are manufactured. On Mars, they now drifted through the air. Their origin? Unknown. But the timing aligned with the craft's new geometry, as if each pass seeded a layer. And still, it never spoke. No signal, no repeat, of the prime code. Only presence, reconfigured, expanding. Meanwhile, another anomaly surfaced. The United Arab Emirates orbiter, HOPE, recorded a brief but measurable drag force, as if it had passed through a region of altered density. No gas could account for it, no field, no visible matter. But the data showed a subtle deceleration. And when that segment of space was imaged later, nothing remained, except a faint circular band, a halo, where the stars behind had blurred lens-like for just one frame, as if something invisible had been there, and then wasn't. It didn't look like movement. It looked like testing. Testing assumes feedback, and feedback implies expectation. By October 13th, that expectation became visible. For the first time, something responded from the ground. The region northwest of Gale Crater, the same zone where left-handed organic compounds had been found, began to emit. Not light, not radiation. Magnetism, localized, structured magnetic pulses, recorded by both MAVEN and the Chinese orbiter Tianwen-1. The pattern was low frequency, layered and recursive, forming clusters of 3 ascending amplitudes, then resetting. Mars does not generate such fields. Its magnetic remnants are fossilized in crust, ancient, fixed, non-responsive. Yet here, the signal pulsed with temporal structure, as if induced, from below. Simultaneously, surface temperature maps from ESA showed narrow strips of warming soil, elongated zones stretching nearly 800 meters, no more than 10 meters wide. They weren't tied to solar input. They tracked beneath the orbital path of the craft, not directly, but offset, trailing it, as if responding to its passage, or anticipating it. No instruments on the ground had moved, no atmospheric shift had occurred, but the Martian surface was beginning to act like a receiver. Back in orbit, the craft adjusted, subtly. Its radial arms, previously symmetrical, now folded inward at irregular intervals. Each rotation passed faster. The sweep cycle dropped from 91 minutes to 68, and with it, the upper atmosphere ions shifted again. Not H3+ this time. Adenine traces, not stable, not structured, but detectable in the chemical ionosphere, a component of RNA, never confirmed in space before, never reported on Mars, now suspended briefly in the thinning air. It disintegrated quickly, but it had been there. Engineers cross-checked every possible explanation: contamination, artifact, miscalibration, all ruled out. This wasn't a message. It wasn't communication. It was compatibility. Something was testing the Martian environment, not for life, but for life potential. And it was doing so with tools no human had sent. Not all signals are meant for receivers. Some are meant for responses. By October 14th, Mars had begun to respond. The magnetic pulses from the Gale region intensified, now forming concentric patterns that rotated slowly over time. What was once a simple repeating field had become a dynamic structure, shifting in phase and amplitude like a low-frequency echo of something larger. These were not side effects. They were reactions. From orbit, the Trace Gas Orbiter recorded trace elements in atmospheric recombination that had no precedent. Bound nitrogen clusters forming spontaneously under conditions where no catalyst should exist. Nitrogen, vital for life as we understand it, is rare in usable form on Mars, yet here it was, forming not by accident, but in structured patterns, in narrow corridors beneath the craft's path. Meanwhile, at surface level, both rovers recorded behavioral anomalies. Perseverance experienced short, repeating delays in its soil sampling arm, pauses that aligned exactly with the craft's sweep overhead. and Curiosity's internal accelerometers logged minute vertical oscillations, not enough to shift the frame, but enough to suggest micro-pressure variations in what should have been dead still air. There was no wind, only a pulse. At orbital altitude, the craft changed again. Its arms fully retracted, its silhouette compressed, no longer symmetrical. It had taken a stance, and with that, it began to descend, not quickly, not directly, a glide path, low angle, controlled velocity. The object passed through 40 kilometers, then held, hovering between layers of atmosphere where nothing should fly and nothing should hover. But it hovered, and below it, something began to rise. ESA's orbiter captured the first images, a vertical column of dust and micro-ice crystals, thin, structured, climbing skyward from the southern highlands. It was not a storm. It was not heat convection. It was alignment. The column tracked with the craft's position as if tethered by field, a narrow bridge of particles suspended between surface and sky, not physical, not visible in full spectrum, but present and persistent. And now, between craft and planet, something hung, not communication, not contact, connection. Bridges are not always built to carry weight. Sometimes they are meant to balance it. By October 15th, the column rising from the southern highlands had stabilized. Orbital sensors no longer classified it as a dust event. It was now a structure, not physical, not in the traditional sense, but measurable, a coherent vertical zone of altered refractivity, extending from the surface to just below the hovering craft. Spectroscopy revealed something stranger, coherent spin alignment in suspended particles. The dust wasn't just floating, it was oriented. Each grain, no larger than a red blood cell, spun along a unified axis, like iron filings in a magnetic field. Except there was no magnetic field, no electrical discharge, just a shape suspended in planetary air reacting to an origin not seen. And yet it held. A standing column, 22 kilometers high, 300 meters wide at base, tapering as it rose like a pillar built of atmosphere itself. Below, the surface had begun to change. Localized warming around the column's base reached Palklananidog above surrounding regolith temperatures. No sunlight, no geothermal source, no venting, just heat, shallow, surface-bound, and static. Rover sensors flagged it as abnormal, but not dangerous. Perseverance was ordered to hold position, not due to risk, due to unknowns. Meanwhile, orbital instruments recorded something new. Trace particles in the upper atmosphere now included phosphorus compounds, specifically phosphites and orthophosphates. Phosphorus is essential for DNA, RNA, and cell membranes, a rarity on Mars. And now it floated in the air. Simultaneously, thin bands of ultraviolet fluorescence began to ring the column's upper perimeter, faint, cyclic, like a corona, shifting from violet to near invisible, with each rotation of the craft above. It pulsed every 19 to 94 seconds, the same interval as the harmonic pulse first detected days earlier, only now it was visible. Below, seismic monitors logged micro-tremors radiating outward from the base of the column, not from beneath, from within, as if the air itself had become a speaker, a medium. And then, the first surface change. ESA's infrared mapper detected crystalline growths in surface dust within 1.2 kilometers of the column. Fractal structures, branching, symmetric, forming from mineral compounds already present in the soil. No delivery, no insertion, just activation, under temperature, under field. The regolith had begun to assemble, not randomly, precisely. And above it, the craft did not move. It watched. Not all assembly requires parts, sometimes only conditions. By October 16th, the crystalline formations on the Martian surface had multiplied. They were not large, no taller than a few millimeters, but they grew in patterns not native to Mars. Hexagonal symmetry, layered growth, spatial orientation aligned with the position of the craft above. In other words, they were not drifting, they were forming. Spectral analysis confirmed these were not foreign materials, no external compounds, no unknown alloys. The crystals were made from native Martian silicates, restructured, a phase transition not seen before under local conditions. No heat, no water, no applied energy, only field, and only here. The column between the surface and the craft still held, refractive, spinning, stable. Its perimeter now extended horizontally into a faint ring at altitude, like an aerial platform built from invisible threads. The entire system, craft, column, surface, behaved like a single mechanism, and it had changed modes again. Above the visible band of the column, MAVEN's sensors picked up rotational turbulence in the upper thermosphere. Wind shear velocities increased, not chaotic, but radial, like stirring. At the same time, solar wind deflection near Mars increased by 4%, as if the planet's magnetic shadow had expanded. But Mars has no magnetosphere. At least it didn't. Now, it was behaving as if it did. A temporary shield, a byproduct, or an intentional field envelope? No one could say. But the data was undeniable. Meanwhile, back on Earth, teams at the Deep Space Network recalibrated long-range receivers. On October 16th, at 02:17 UTC, a signal was detected from beyond Mars, not from the craft, from behind it. A weak transmission, directional, short duration, but familiar. A prime sequence, again, but longer this time, 2, 3, 5, 7, 11, 13, 17, all the way to 9 to 10. The signal contained no modulation, no embedded message, just order. A mathematical progression beamed into open sky, not toward Mars, away from it, as if a log had been closed, as if a process had reached a checkpoint. No further signal followed, and above the still growing crystals on the Martian surface, the craft finally moved. Not up, not away, but lower. Descent is not always approach. Sometimes it is calibration. By October 17th, the craft had lowered to 31 kilometers above the Martian surface. No thrust observed, no propulsion signature, but its vertical velocity had decreased again, now near zero. It wasn't landing. It was hovering in a new layer, directly above the refractive column, and below, the changes continued. The crystalline growths had expanded across a 2-kilometer radius, still shallow, still silent, but forming a contiguous field. Spectral imaging showed slight luminescence at night, not visible to the eye, but present in ultraviolet bands. A kind of phosphorescent haze, pulsing once every 94 seconds, matching the corona at the top of the column. The system, from dust to orbit, was now oscillating, in sync. Above, the shape of the craft changed again. Its surface shifted, not physically, but optically. New geometries appeared, darker than the sky, irregular, almost fractal outlines projected across its form. Radar return weakened. Infrared vanished. Optical clarity dropped. It was becoming less visible, not cloaked, just hard to resolve. Edges blurred, reflections dispersed, as if it was aligning itself with the noise floor of observation. And yet it was still there, perfectly still. Meanwhile, inside the growing crystal zone, temperature variation reached zero. No diurnal shift, no night-day cycle. Constant thermal regulation despite ambient planetary conditions. The ground was no longer behaving like regolith. It had begun to function like material, structured, ordered, and responding. Then came the first known effect on non-Martian systems. Hope orbiter, passing overhead, recorded minor fluctuations in its gyroscopic instruments, a subtle drift, uncommanded, transient, but repeating, each time it crossed over the crystalline zone. The disturbance was localized, no radiation spike, no electromagnetic burst, just orientation disruption, as if space itself, in that one column of air and ground, had begun to behave differently, not violently, just precisely. And still, no signal, no demand, no threat, only continuation. Listening does not require ears, only alignment. By October 19th, the pulses beneath the Martian surface had intensified, not in force, but in pattern. The 77-minute interval held. But now, each cycle carried subcycles, microbursts at precise harmonic multiples, radiating outward across the crust. It was no longer a vibration. It was a clock, set in the bedrock. Meanwhile, orbital spectrometers detected elevated trace elements above the crystalline field: hydrogen cyanide, thiols, formaldehyde. All are known prebiotic compounds, all unstable, all now stabilized in the Martian upper atmosphere, suspended, not globally, but within a 60-kilometer cone above the field, an atmospheric cradle. And still, the craft remained silent. Its form, low contrast, difficult to track, held position precisely 31 kilometers above the center. No visible movement, but new visual patterns appeared across its surface. Not blinking, flowing, waveforms, dark against dark, rippling from its center outward like liquid glass under vibration every 1994 seconds. Still that rhythm, still that pulse. On the ground, ESA's seismic monitors picked up new interference, cross-frequency noise, not natural, not terrestrial, but recognizable. It matched test patterns used in Earth-based calibration of synthetic aperture radar, a tool for imaging surface structure. Mars was now reflecting that signal back, not with data, with structure, as if it had become the instrument. Back on Earth, the Deep Space Network confirmed it. For the first time, radio scatter from Mars exhibited internal phasing consistent with passive modulation. The planet was no longer absorbing signal. It was shaping it. No information, no message, only modulation, form without content. At least, none humans could detect. Above, the column connecting ground to craft remained intact, but its visual signature had changed. No longer a vertical haze. Now it was banded, horizontal layers of alternating transparency like stacked lenses adjusting focal depth. Not a conduit, a filter. The craft itself began to flicker again, subtly, not in position, but in outline, as if its visibility now depended not on light, but on context. Context does not require understanding, only compatibility. By October 20th, the entire region beneath the craft had entered thermal stasis. Surface temperatures remained constant across both day and night cycles, unaffected by sunlight, shadow, or planetary rotation, a 5-kilometer zone of environmental equilibrium. The crystalline field no longer expanded outward. It thickened downward. Subsurface imaging revealed a shallow layer of reorganized material extending nearly 40 centimeters below the surface, not deposited, transformed. Mineral structure altered at the molecular level, preserving composition, changing geometry. Martian soil had become something else, still inert, but no longer passive. Meanwhile, orbital data confirmed that the column of air connecting ground and craft was now resonant. Acoustic pulses, subaudible, regular, harmonic, cycled vertically every 11.2 seconds, not from above, from within. The column was singing. Above it, the craft initiated its first major structural shift in days. Its surface geometry compressed, bands of low reflectance material receded, revealing a central aperture, not a hatch, not an opening, a void, geometrically perfect, blacker than sky, absorbing not just light, but signal, radar, lidar, infrared. Nothing returned, only silence. But from that aperture, something emerged. Vibration, not physical, not measurable in displacement, but recorded across 5 separate orbiters as data jitter. Time signal drift of less than 2 milliseconds, synchronized across platforms. Earth-based analysis confirmed it. Time had been nudged, briefly, precisely, and only in one direction, forward. Not a glitch, not noise, a shift. It passed. But it had occurred. Meanwhile, Curiosity, still hundreds of kilometers away, recorded one more anomaly. Its onboard atomic clock had drifted by 0.004 seconds, then resynchronized. No error reported. But in the log, one word was flagged for the first time since the mission began: external sync. The planet was aligning. Alignment is not an end. It is a precondition. By October 21st, the aperture at the base of the craft no longer absorbed only signal. It absorbed time, not literally, but operationally. Orbital systems crossing directly beneath it reported unexplained desynchronizations between expected telemetry timestamps and received data. Tiny gaps, consistent, patterned, as if data itself had stretched slightly in transit, not delayed, dilated. ESA described it as non-relativistic lag, a term with no formal standing, only as placeholder for an effect with no known cause. On the surface, the crystalline field responded in kind. Sensors registered minor but measurable latency in electronic signal propagation between rover modules. Internal systems remained functional, but slightly out of phase. Each ping of onboard diagnostics returned a fraction of a second behind schedule, then corrected, then drifted again, like a clock syncing to something else. Meanwhile, the standing column between craft and ground began to pulse at a new interval, no longer 19 seconds, now 23.02, a Fibonacci shift. The spacing between pulses lengthened in accordance with a golden ratio derivative, a signal not in binary, but in growth. Above, the craft's geometry continued to evolve. No new structures appeared. Instead, existing lines refined. Edges became smoother, curves more pronounced, as if the vehicle itself were responding to resistance not encountered, optimizing for an environment that had already accepted it. The aperture remained open, but now it rotated 1 degree per minute, in perfect alignment with Mars's axial spin, not tracking anything, joining it. And from the surface came one more change. A single crystal at the center of the field fractured, not from pressure, not from heat, from completion. Its internal structure had reached maximum complexity and could no longer hold its form. Spectroscopy confirmed it had become biologically unstable, not alive, but ready. The silence held. The shape above did not descend, but Mars, it seemed, had toward something. Activation is not ignition, it is continuity made visible. By October 22nd, the central aperture of the craft had stopped rotating. Its alignment with the Martian spin was complete. No signal followed, no change in emissions. But a new element appeared: shadow. A circular zone beneath the aperture, 800 meters wide, began to darken, not in light absorption, but in reflectance. Soil albedo dropped by 23%, then 41%, then stabilized at 53%. No change in sunlight, no dust, no atmospheric occlusion, just matter behaving as if it were darker. Spectrometers showed no material difference, but photons, for reasons still unexplained, were being redirected. The zone became optically quiet, and inside that zone, instruments recorded the first vertical particle displacement from below. Not ejection, not eruption, a rise. Silicate dust, no heavier than smoke, began to lift from the central region, not blown, not drawn, but unanchored. It hovered at knee height, then settled again, then rose once more, a steady cycle, no disruption to surrounding terrain, no pressure differential, just lift. Above, the aperture of the craft shifted again, not closing, but inverting. The internal blackness became reflective. For the first time, orbiters saw stars mirrored inside it, but not the same stars. Their positions were wrong, slightly skewed, as if the reflection obeyed a different curvature. Engineers proposed lensing, some suggested simulation, but the effect held only within the aperture, a window to something else. And yet nothing emerged, no beacon, no transmission, just a field of stars drifting gently, disconnected from Mars, disconnected from Earth. And still, the crystals below held their glow. They did not spread. They did not multiply. They waited, in perfect order, within a zone that now absorbed light, reflected alternate geometry, and rose grain by grain into a machine that never declared its purpose. Because perhaps it didn't need to. Completion rarely announces itself. It just stops changing. By October 23rd, nothing new had appeared, no motion from the craft, no new formations in the crystalline field, no pulses in the atmosphere. For the first time in 12 days, Mars was quiet, not passive, not dormant, just stable. The aperture at the base of the craft remained open, still reflecting skewed stars, still offering no transmission, no sound, no field interaction. The hovering dust within the shadow zone settled permanently. Sensors registered a halt in vertical displacement. No lift, no descent, no charge. The material simply came to rest and stayed there. Ground instruments from both Perseverance and orbiters reported a flattening of anomalies. Signal jitter ceased. Timing drift self-corrected. Spectral noise dropped to baseline. The Martian crust no longer vibrated. The pulses stopped. The magnetic echoes faded. The air stilled. It was not a shutdown. It was a plateau, as though every part of the process from dust to orbit had reached operational steady state, and from that point on, remained unchanged. The craft didn't leave, didn't land, didn't transmit. It just existed in a fixed relation to the zone beneath it. A machine not doing something anymore, but being something. Its surface no longer shimmered, its outline no longer blurred. It had resolved into a perfect geometry. So still, it required software to confirm that it hadn't become a glitch. Below, the crystal field no longer reacted to sunlight, but it didn't fade. It glowed faintly, continuously, without variation. Temperatures remained stable. Spectra remained fixed. Electromagnetic emissions dropped to undetectable levels. It was a system that no longer asked questions and no longer answered them. A system that had become its own result. Variables don't demand meaning. They change the meaning of everything else. By October 25th, Artifact A1 had been fully integrated into navigational charts. Rovers routed around it. Satellites avoided direct overpasses. Landing protocols excluded its zone entirely, not due to risk, but redundancy. There was no interaction to consider, only presence to respect. Scientists debated new nomenclature. Some referred to it as a construct, others called it a fixture, but most simply stopped describing it at all, because nothing about it changed. And in science, what doesn't change becomes infrastructure. The field beneath the craft no longer emitted any heat differential. It blended into Martian background readings, save for one anomaly, a perfectly circular zone 800 meters wide that remained unchanged by wind. Dust storms passed over it. Sand drifted to its edge, but nothing entered. No material, once inside, left a mark. Tire tracks from early rover incursions were still there, unblurred, unburied, as if time itself paused at the boundary. No one claimed the zone was temporal. No one called it a stasis field. But in every instrument and image, the area persisted in memory, unmoved, unmossed, unerased. The stars reflected in the aperture never matched the real sky, but they didn't move either. They remained in slow drift, caught in a geometry no telescope could trace, like a still photo of a sky no longer accessible. One astronomer described it as a map to a place that doesn't exist yet. But no further research followed. There was nothing left to observe, no feedback, no anomaly, no escalation. The event had not concluded. It had converged into something indistinguishable from Mars itself, a part of the terrain, a constant. And for the first time in the history of exploration, humans had encountered something that answered no questions, but removed the need to ask. Not all conclusions are ends. Some are absorptions. By October 26th, there were no new entries in the mission logs, no new anomalies, no course corrections, no alerts. The field beneath Artifact A1 no longer required classification. It was listed simply as Zone 0. Its parameters were noted. Its metrics remained unchanged. No team was assigned to monitor it full time. There was nothing to monitor. Above it, the object continued to cast no shadow, emit no signal, generate no field, except the constant one of presence, a presence with no outcome, no escalation, no disappearance. It did not complete a cycle. It became the cycle. When Deep Space Network antennas swept past Mars again, there was no return ping from behind the planet, no prime number signal, no alignment anomalies, no trace of a secondary craft. The sky was quiet, not empty, just done speaking. Engineers submitted final telemetry corrections. The anomalies variables were folded into baseline modeling for future Mars operations. It became a factor, not a threat, not a mystery, just a factor. The only lingering note in the final ESA report read, "Recommend. No further attempts at contact. Recommend. Respect of boundary." And so the boundary remained, not guarded, not feared, simply left alone. A silent point in the solar system, unclaimed, unmoving, permanent, like an answer to a question no one had ever spoken aloud. It has not moved since.